Welcome to Third Angle, where we're waving hello to flying robots. I'm your host, Paul Hames from industrial software company PTC. In this podcast, we share the moments where digital transforms physical and meet the brilliant minds behind some of the most innovative products around the world, each powered by PTC technology. The Istituto Italiano di Tecnologia, or IIT for short, is a scientific research center based in Genoa, Italy, that had collaborations with PTC partner Parametric Design. One of their areas of research is the development of humanoid robots. Their first model of robot was called the iRonCub, a child-sized robot which was able to crawl, interact with people, and pick up objects. They have since developed other models, including the ErgoCub and iRonCub. The ErgoCub is designed to assist human workers in factories. It stands at 1.5 meters tall and can carry loads of up to 10 kilograms. The iRonCub is an aerial robot, able to assist emergency services in disaster zones. It's able to fly using jet engines mounted on its arms and a jetpack attached to the robot's back. IIT believes that these humanoid robots could be working alongside humans in the next 10 years or so. Our producer, Carola Haupt, visited the IIT headquarters in Genoa, Italy, and spoke to Head of Artificial and Mechanical Intelligence, Daniele Pucci. Daniele takes us on a tour around their lab and tells us about how these robots will be able to address problems facing humans now and in the future.
Hey, ErgoCub.
Yes?
What can you do for me?
As ErgoCub, I can assist with physical tasks, understand speech, and collaborate safely.
So, my name is Daniele Pucci, and I am the principal investigator of one of the research units of IIT, namely the Italian Institute of Technology that we usually call IIT. And basically, I lead the artificial and mechanical research unit. So, within IIT, we are really focused on merging multiphysics with artificial intelligence in order to generate new devices in the form of intelligent robots. So we are basically in the room which has the highest density of humanoid robots in Europe. So only in this there are 2, 4, 6, 8. So there are about now 10 humanoid robots, and we have several evolutions of the iRonCub. So the first one is there. We can go there. So this is the first version of the iRonCub, and it's the SN000. It looks like basically a kid, a 3-year-old kid, and one of its somehow really uniquenesses are the hands, which is incredibly dexterous, and then also another somehow unique feature of the iRonCub are the eyes. So we've been working on for years on eyes that work a little bit as the human retina, and which means that they are sensitive to variations. They can track what changes. So ErgoCub can recognize people, can move objects around, can carry payloads up to 7-8 kilos, and then could push buttons, take objects, so these kind of things, and walk around, clearly. ErgoCub, what do you see?
I see people, a microphone, and a robot on a desk.
What is the color of the shirt that I am wearing?
It appears you are wearing a blue shirt.
Can you walk towards me?
I'm moving forward.
So when I saw the robot, I said, why don't we make it fly? Because actually, I came from France where I was working on drones. Okay, I said, no, come on, we have to make this guy fly. Okay, and that was back in 2013. Okay, the first time. Yeah. So, so how does it look, this guy? So this guy is a 1.2, it's a humanoid robot, 1.2 meter tall. There are 4 jet engines attached to the robot, 2 at the arms and 2 in the backpack. These engines are basically little turbines out of which there is gas going through the nozzle at 800 degrees Celsius and supersonic speed. And then basically the humanoid robot had to be redesigned in its lower legs, because you have basically 2 big problems. So the first one is temperature. The exhaustion gas is at 800 degrees Celsius, so it melts things. And the second one is dynamic pressure. So the velocity of the nozzles breaks things. So you have dynamic pressure and temperature. So you have these 2 problems to deal with. And that's why we had to redesign the lower body of the robot. Okay, so it didn't have to melt and didn't have to break. And this is it, basically. Sometimes people say it looks like an Iron Man. I don't know if it looks like an Iron Man, but it reminds the Iron Man. Yeah, usually people say, why are you doing this crazy thing? Okay, so let's start from the why. So the why is that there are 3 reasons. So the first one is that it is after a tsunami, after an earthquake, you have floods, fire, and so you would like a platform that basically avoids floods and fire, then lands in like a partially destroyed building, that starts moving inside buildings, and then so which means that you need terrestrial locomotion like legs. So you are flying over floods, you have to fly over floods and fire, you have to land, and then you have to move with legs, and then you have to open doors, you need hands. So you need 3 skills: flying, walking, and manipulation. The humanoid robots, then, if you take jets, you give them to humanoid robots, you did the job. Okay, so the first one is pragmatical. The second one is that it's an incredible good, let's say, gym for research. So this is it provides a lot of problems. Okay, you have thermodynamics, aerodynamics, control, artificial intelligence, and it scales the problem to another level. Okay, because for instance, aerodynamics, we are working with aerodynamicists of Stanford and Politecnico di Milano. They got excited because aerodynamics of shapes that change there, they got excited. And you have to build these models that can predict aerodynamics, thermodynamics. So it's a very important gym for research. So you can push your research boundaries into fields that you wouldn't have done without it. So, human-robot interaction is something that sometimes, when we think about it, we don't really understand the impact that human-robot interaction has on human lives. Not only at, let's say, physical level, but also the way we interact between each other. Just to make concrete examples, so there are studies that show recently that kids somehow start behaving differently with their parents after getting, like home robots, like Alexa. Because, for instance, they order things without even say thank you after interacting with a robot, like Alexa. And when then the parents get back home, they don't even say can you do that? Not even answering thank you. Okay, so those examples really make us think that human-robot interaction will have an incredible impact, not only in our daily physical jobs, but also the way that we will construct interactions between us. And here at IIT, we are working across different, let's say, flavors concerning human-robot interactions. There are people who are trying to understand the social impact of robots. There are people that are trying to understand how also robots should look like in order to be accepted. So also the impact of design. And there is also people like us that are more concerned about physical human-robot physical interaction. So we are envisioning a society where it's composed of humans and robots working together at the physical level. And we're trying to take steps in this direction in order to integrate humans with humanoid robots at the physical level. So tasks that we're thinking of is a robot collaborator in a warehouse or an hospital, and then he has to understand my physical needs, and then he has to understand when to intervene and when not to intervene in order to, for instance, reduce the risks of workers.
So I'm Giovanni Fregonese. I'm a PhD student here in the MEI lab and under the University of Manchester. And what I do is trying to integrate the new AI models, large language models like ChatGPT, Gemini, and that kind of stuff into the robot and into the intelligence of the robot. So my work is mostly programming and trying to make the robot talk, speak with you, and also integrate the motion part of the robot with the intelligence of these language models. We can ask it to do certain actions. So, hey, ErgoCub.
Yes.
Can you wave?
Of course. Waving now.
ErgoCub, stop. So the challenges are like data collection, because to train the models for these motions, we need a lot of data. And we don't have that many robots. And so...
You are right. Data collection is challenging to train models for motion.
It is great.
Yes, and the other big challenge is actually integrating this data and make all this machine learning and AI tool work.
So what is then the ethos of making humanoid robots? Yeah, basically the current factories, European, Italian, need to be digitalized. Okay, so if you have a factory, you have basically two ways in order to digitalize your factory. The first one is that you basically put it down and rebuild it with automatic systems. But this is really costly in terms of time and money. The second one is to insert into factories that are designed for human beings a versatile and adaptive, less invasive element, which is a humanoid robot. So instead of changing the infrastructure of the factory, you insert an element that is adaptive. So you do not put automation systems into the walls, but you create a mobile automation systems that can be a sensor and an actuation. Now industries are putting giant amount of money in industrializing humanoid robots, but giant. So it means that basically humanoid robots will become like the next drones. We remember, everybody remembers what happened with the drones in the early 2000s. You saw drones in labs, and after 10 years, you go to the store market and then you can buy them. So probably, okay, this is something that might happen also for humanoid robots the next 5 to 10 years. So we might meet each other in 5 to 10 years, and you might go and look for your own desired humanoid robot in 5 to 10 years. As a zoom out, we are working on two big societal problems. So if you look at the numbers, the projections of human beings is clearly saying that humans will be less in the next decades. Only Italy by 2100 is projected to pass from 60 million to 36 million. So this poses a big problem. Okay, so physical tasks, we won't have hands in order to do physical tasks. So this is a problem that it's coming. We know that. So the so-called demographic crisis. The other big problem that is not a problem of the future, it's a problem of the present, is that the current workforce is somehow it's really fragile. So if you look at the numbers, for instance, in Italy, you clearly see that workers stop their activity because of back pain, for instance. So 70%, just to be more precise, in Italy, 70% of the total number of reports for workers that need to stop their activities because of back pain. Okay, so this means that we have two big problems. One is a problem of the present, which is a fragile workforce, and then a problem of the future, that this workforce won't have substitutes in order to sustain the same level of goods and services. So we need technologies that somehow protect the current workforce and will compensate for it in the future. And that's what we are working on.
That was Daniele Pucci and PhD student Giovanni Fregonesi, sharing IIT's vision of the future where robots and humans work side by side. Now it's time to meet our expert, Brian Thompson from PTC. Brian, IIT uses PTC Creo as its 3D CAD design software. They use the Creo Mechanism Dynamics option for planning, control, and simulations of their Cub robots. Are you able to give an overview of this Creo module and how it can benefit users like IIT?
Yeah, sure. I'd love to. Mechanism Dynamics option gives a way for design engineers to connect the kinematics of an assembly, which is how various linkages in the assembly are connected together and how the motion of that assembly is intended to operate, to the actual loads that the system sees as the mechanisms are being acted on by accelerations, either by motors or by external forces. And so it's actually the kind of engineering that is done in a lot of dynamic systems when there are gear passes, pulleys, other sorts of levers and mechanisms, which, as you might imagine in a robot, a humanoid robot, there is quite a bit of that. What engineers need to do is they need to provide the dynamic inputs to the system, and the mechanism dynamics options will solve the entire mechanism system with those dynamic inputs and provide loads at the various locations in the system. And even better than that, we will allow you to take those loads that come from the output of the analysis, of the dynamics analysis, and we use those loads as an input into structural simulations. So you not only know the loads, but you can then immediately transfer those loads into finite element analysis done right there in Creo on the assembly. So that way you can get a really good full picture of what's happening to the system. It's very sophisticated stuff, but for a mechanical design engineer working on a system like the one you see with these humanoid robots, it's going to be absolutely required. And so one of the great benefits of the way MDO is built is that it's built right there inside of Creo. The design engineer doesn't have to leave the environment to perform the type of simulation that we're talking about here. It's just part of the design process like everything is in Creo. And so I think that's why users really love this integration.
Thanks to Brian and to Daniele, Giovanni, and our producer, Carola, for taking us behind the scenes of IIT. Please rate, review, and subscribe to our bi-weekly Third Angle episodes wherever you listen to your podcasts, and follow PTC on LinkedIn and X for future episodes. Companies that make products the world relies on, rely on PTC. This is an 1860 production for PTC. Executive producer is Jacqui Cook, location recording by Carola Haupt, sound design and editing by Clarissa Maycock, and music by Rowan Bishop.